we'll start. Today we'll create a workflow on Data Science Workbench of BDB platform. We'll enter, as you can see here, there are multiple workbenches which are available on BDB platform. One is deep learning workbench for neural networks and image and text processing. R and Python workbench, and there is Spark ML for big data and distributed ML for which is used for a huge data set which can't be processed all at once. So today we'll be using the Python workbench. So once you enter in the Python workbench, we'll be in today's demo. We'll be using the telecom churn data, which will contain the customer demographics as well as the plan which has been subscribed by the customer. All these data sets, all these data points will be there for all the customers. So I'll upload a CSV from the data source. There are multiple data sources with which you can ingest the data set. One of the ways is CSV. You can use Excel file. You can use SQL database. You can use Elastic data source, and you can use zip file as well. So I'll use CSV. From my local, I'll upload this customer churn file. I'll upload the file. Run the workflow so that we can see it in the result tab. It will take a few seconds to complete it. It contains around 2,000, 3,000 rows of data. Let's have a look at the data set. So here, as you can see, there's a customer ID column, the gender, senior citizen, whether the customer belongs to a senior citizen or not, partner, whether the customer has taken a partnership or not, dependents are there or not, tenure or phone services, and multiple lines. So this partner is basically they have a partner or not. So it's a demographic details of the customer as well as the the packages which they have opted for in the telecom services they have opted for. For example, streaming TV, streaming movies. These are the services which they have opted for. What is the type of contract they have taken, and the payment methods by which they pay the bills, and the monthly charges and the total charges which they have on an average. So all these details are there in this data set, and what we are trying to predict is whether the customer will churn or not. This is the target which we are trying to achieve through this. So we already have a labeled data set on which we will be training our model. So first step will be a data preparation step, which is so in data preparation there are multiple things which you can do. You can replace missing values. You can normalize the data set, split data, which we'll be using for for train and validation splitting. So once you enter the split data, you can give, say, 80% of the data I'll use for training. You can use whatever you want in your application. So once it's ran, it will be only showing me it has split the data set into 80 and 20%. Now, once I have split the data set, I can actually use multiple data preparation components as well. So you can filter the columns and rows if you want. You can use create new features, new columns based on the formula features by combining different columns. Then after splitting the data, I'll be using one of the algorithms there are multiple algorithms which are present. So I'll be using one of them. Let's take random forest, because this is a standard classification algorithm which I'll take. So here you can select whether it's a classification problem or a regression problem. Here we have a classification problem. You want to show the probability, which I don't. I can select the features. Check all. I don't want to take customer ID because it doesn't add any value. It just creates random numbers. And the target column I'll remove. Other than that, I'll choose all the columns which are present. And if you can see, I have actually taken the categorical and the discrete columns, all of them together, the numerical and the categorical columns together. So it takes internally handles all the data, the categorical data as well. So the component which we are using at the back end, it handles the categorical data by itself. We'll use Churn. We'll change this name to Dr. Churn. If you want, you can use hyperparameter tuning. If you don't, you can actually give your own hyperparameters. Just to complete it fast, I'll use this and let's apply. You can go with the defaults as well if it doesn't matter. So I'll run the workflow. It will take a few seconds to train the model. The model is getting trained on the 80% data which we have taken out of this full data set. Let's give it a few more seconds to complete. So till the time it completes, what we'll do is, after training, we'll be applying this model to the rest of the 20% data. So for that, we need a apply model component. We'll be using this apply model component, and once the model gets trained, we'll actually attach it. And then the second node of the split data, which is the 20% of the actual data, will use it for validation, which is how the model will be used for validation, how good the model is on the data which it has never seen. So as it is a more complex model, it is taking some time. So let's give it a few more seconds, and then we'll move forward. And we'll apply this. Let's rerun this. Now the model is completed. It has trained as well as it has applied it. We can see the result in the result column. There will be an extra column which is the predictions of the model on the validation set. Now if you'll see, there's a summary which is attached with it. So if you'll see in the model, there will be a summary which will be having an accuracy score. So you can see that it's around 86% accurate, and within a few seconds we can train a model which is around 86% accurate. So that's how good the whole interface is. Now you can save this model, the model which you have trained, for using it for inferencing in pipeline or in for deploying that model. So you can give it Churn. You can save it. And now this model is there. Yeah. Any questions? If you want, you can actually write this data to multiple sources. Once the data set is, you have applied the algorithm on your data, you can actually write it to a data store, and you can write it to. You can create a data set from that. You can create a new data store. apply it, and then rerun this. Yeah. Now you have written this into the data store. By using this data store, you can actually visualize the data set which will be showcasing in the next step.